Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos, Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 9. It says the graph of h of x is equal to negative x cubed plus ax squared plus bx plus c is sketched below. And then point number 1, we are given that a and b with coordinate 6 is to 0. So we are given the coordinates here 6 is to 0 are the turning points of h, as we can see. Then t, 3 is to y is a point on h, and then graph of h passes through the origin. Then 9.1 says show that a is equals to 12 and b is equals to negative 36. Now, what you need to note, every time you are given this type of graph here, and then you can only see two intercepts. This is a cubic graph, guys, and then we know that the cubic graph needs to have 3 intercepts. Now, you always have to note that if your cubic graph touches this point here, and then that point is an intercept and also again a turning point, that means there are 2 intercepts. It's just that they're equal, right? So there are 2 equal intercepts. Now you will also remember that from your parabola function, if your parabola function only intercept once, this is where you have something like x minus 2 is equals to 0. So you can see that your answer is just x is equals to 2. But then does that mean that the graph only has 1 intercept? Yes, in terms of looking at it, you can only see 1 intercept. But then this actually means that there are 2 equal roots, right? So there are 2 equal roots. So that means what must you do here? You must repeat that 6 twice, right? So, okay, now what we are going to do here is we're going to use the root form in order to find the equation, because remember, when the question says show that a is 12 and b is equals to negative 36, so they want you to show the values of a and b. What they're actually trying to say is that find the equation of the graph of h of x. So we know that to find the equation, we use the root form method, where we say x minus x1, x minus x2, and then x minus x3. But then looking at this, we can see that the value of a in terms of originally how this is ax squared plus bx plus cx plus d. So the a here is really representing the value of b, and the b is representing the value of c, and the c is representing the value of d. So our a here, the true a from the original formula here is -1. So we're going to replace here with -1. And then now we have x. The first root that we have is 0 here, the first intercept. So that's 0. And then the second intercept is 6. So we're going to write it as -6 here because it's positive. And then that's x. And then again minus, and then we're going to write the 6. Why? Because we are repeating this one twice, because we say at that point we have equal roots. Okay, so now to calculate, we will have the -1, then x minus 0 is just x. And then if we just multiply these ones, that's x squared. So x multiplied by -6, that's going to be -6x. But again, -6 times x, that's -6x. So if we add them together, that's -12x. Now, -6 times -6, that's positive 36, like that. And then what we need to do right now is multiply with this -x here, right? So that means we have -x first, and then that's x squared minus 12x, and then plus 36. Then we can multiply inside with this -x, multiply inside with that -x. Then our equation now becomes -x cubed plus 12x squared, and then minus 36x. Now, looking at this, we can see that at this point, we can clearly see that the a was in this position according to what we are given here. So the a is in that position. That means our a is equals to 12. And then the b is in this position here. That means it is equal to negative 36. And then what about the C? We can see this. The C, they did not ask us to calculate it because looking at it, we can see that we do not have any value for C there because look at this part here, we do not have the constant. So that means our C is equal to 0. So it's not the fact that it's undefined, it's just that it is equal to 0. They wouldn't come here and say plus 0, right? So at that point, we have now found the equation of this graph here, h of x. So let's say h of x is now equals to negative x cubed plus 12x squared minus 36x. And that's where we found the a and the b value. Hey, now to calculate the coordinates of a, so remember a here is the turning point. They told us that a is the turning point along with b. So we know in order to calculate the coordinates of the turning point, we have to first derive. So let's first start by writing the original equation, h of x, which we did calculate. It was negative x cubed, and then followed by 12x squared, followed by negative 36x. Now we know to calculate the turning point, first derive, and then this is negative 3x squared, and then here we have 24x, and then minus 36. Now at this point, we know that h prime x must be equated to 0 at turning points, right? Because we're saying the gradient of the graph on the turning points is equal to 0. So we take that equation for h prime x, and then we equate it to 0. Now at this point, we can see that everything is divisible by 3. So we can divide by negative 3 so that we have a positive here. Then if we divide by negative 3, that's positive x squared. And then we end up with this and that divided by, this is going to give us 8 here. So that's negative 8x. And then here, this is going to give us positive 12 equal to 0. Then when we factorize, that's x minus 6 and then x minus 2, right? So our values are x is equals to 6 or x is equal to 2, right? But then remember, we are looking for only the coordinates of a. The 6, we know that it is applicable to the b here because they already told us that the turning points b, the coordinates of b are 6 is 2, 0. So we know that in finding our x values, we are finding the x coordinates of the turning points. So the x here applies to the b. So that means the 2 here applies to the a, right? And then looking at where it is in the Cartesian plane, it makes sense. Now to calculate the y value, because we are looking for the coordinates, that means we take this same x value and we substitute it back into the original equation. Remember, to find the y coordinate, we substitute back into the original equation. Then 12, and then here we have 2 squared. So make sure that you are substituting into the correct formula, and then you are also mindful of your exponents, right? And then when we do that one, it's going to give us negative 32. So that means our coordinates for a are now 2 is equals to negative 32. And again, looking at where it is in the Cartesian plane, it kind of makes sense. So that's 2 is to negative 32, right? Right. And then just like that, you have your 3 marks. Okay, so 9.3 was saying calculate the value of y. So to calculate the value of y, you can see that t here lies on the graph of h. So that would be pretty simple. That means we are already given the x value. So all we are doing is just substituting that x value into the original equation so that we find y. So that's negative. And then here we have 3 and then cube, and then followed by plus 12, and then 3, and then square, followed by negative 36, and then 3 again, right? So when you punch that into your calculator, it's going to end up giving you a negative 27, right? So that means, in other words, our y is equals to negative 27. So our coordinates for t are 3 is to negative 27. But remember, they only said they want the value of y for 1 mark, right? Then 9.4 now is asking, is the graph of h concave up or concave down at point t? Right. Now, remember, anything that touches on concavity, we have to respond it using the what? The point of inflection. Hence, we have our 3 marks, right? So first is to get the point of inflection, and then we can comment on whether point T there is concave up or concave down, right? So, okay, that's X. To calculate the point of inflection, remember the easier method is just to take the X coordinate of the turning point and then add them together, then divide them by 2. So 2 plus 6 divided by 2, we have 8 divided by 2. That's going to give us 4, right? And then once we have our X coordinate there as 4, then we can say, okay, our point of inflection must be somewhere here just after the point T, right? So just after the point T, that's where we are supposed to have our point of inflection, right? Now we want to find out, if at point T, the graph is concave up or concave down. Now looking at this here, we can see that just after the point T, we can see our graph is becoming concave down, right? But then after that point, before that point, so after that point, it's becoming concave down. But before that point, what was happening? We could see our graph was concave up, right? So yellow for concave up, and then purple for concave down. Now, where is point T? Point T, we can see that it is just before the point of inflection, meaning point T lies at the position when your h of x was still concave up, right? So it lies at a point where your h of x was still concave up. So we are supposed to say T, the graph of h at T is concave up, right? It's concave up. Why? Because we can see that our x coordinate of T is coming before the point of inflection, right? So our x coordinate of T is less than 4, which is the point of inflection. So if it's before the point of inflection, that means it is still concave up there. But if it was after the point of inflection, then we would say the graph at that point is concave down, right? So that's how you were just supposed to go about answering that question, right? And then now 9.5. So this here note, we were answering 9.4. So for 9.5, it's now saying determine the coordinates of the point of inflection, and that's only 2 marks. Now note that it's saying coordinates. Now you might ask yourself, do I need to still repeat the process of finding this x value here? No, you already have the x value, which is the point of inflection itself. And then now you want the coordinates, meaning you want the x and the y coordinate. So you can just simply take your x coordinate, substitute it into the original equation there of your h of x. So your h of x is equals to negative x cubed, and then followed by plus 12x squared, followed by negative 36x. Then what you are doing to find the coordinates of the point of inflection is just taking this h of x and replace 4 with this x. So substitute by 4 with this x. So there you go. And then minus 36, and then here you have 4. And then you just punch it into your calculator. So you get your value as negative 16, right? So that means the coordinates of the point of inflection are 4 is to negative 16. And then you are done, right? Okay, and that's how you were expected to tackle this question for a total of 12 marks. And then with all that being said, if you have enjoyed the lesson and then you have found it helpful, please press the thumbs up button. And if you've been watching the videos and haven't subscribed yet, please, please, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.